In the year 1632, on the sandy banks of the Yamuna River in the city of Agra, the foundation was laid for what would become the most ambitious architectural project of the 17th century. Commissioned by the 5th Mughal Emperor, Shah Jahan, to house the tomb of his favorite wife, Mumtaz Mahal, the Taj Mahal stands today not merely as a symbol of grief, but as a pinnacle of ancient engineering and logistical mastery. Over the course of 22 years, an estimated 20,000 artisans, architects, and laborers constructed a monument that defied the environmental limitations of its landscape. This is the comprehensive chronological examination of how the Taj Mahal was built, from the subterranean foundations to the peak of its marble dome. Part 1. The historical context and site selection. To understand the construction of the Taj Mahal, one must first examine the socio-political climate of the Mughal Empire in the early 1600s. The empire was at the zenith of its wealth and cultural influence. Emperor Shah Jahan was a prolific patron of architecture, having already commissioned numerous forts, mosques, and gardens. However, the sudden death of Mumtaz Mahal in 1631 during childbirth plunged the emperor into profound mourning. His decree was absolute. A mausoleum of unprecedented scale and beauty was to be erected. The selection of the site was the first major engineering challenge. Shah Jahan chose a plot of land situated directly on the convex curve of the Yamuna River. Aesthetically, this location was perfect. It provided a serene, reflective backdrop and ensured that no future structures could obscure the view of the monument from the river. Structurally, however, it was a nightmare. The soil on the riverbank consisted of loose silt, shifting sand, and a high water table. Conventional shallow foundations would inevitably settle unevenly, leading to the cracking and eventual collapse of any heavy masonry structure placed upon it. Part 2. Subterranean engineering. The well foundation system. Recognizing the instability of the soil, the Mughal engineers, led by the chief architect Ustad Ahmad Lahori, devised a deep foundation system that is still studied by civil engineers today. They implemented a technique known as well foundation, a method previously used in a limited capacity for bridge piers, but never on such a massive scale for a building. Laborers excavated dozens of massive, cylindrical shafts deep into the riverbank, digging approximately 15 meters down until they reached more stable, compacted earth. These were not simply filled with rubble. To ensure structural integrity, the engineers utilized timber casings. They specifically selected ebony wood, transported from distant forests by a fleet of over 1,000 elephants. Ebony was chosen for a specific botanical property. In the absence of oxygen and when perpetually submerged in water, it does not rot. Instead, it maintains its structural density. Once the wooden casings were positioned within the deep shafts, they were meticulously filled with a dense, compacted mixture of iron, mortar, and heavy stone rubble. These subterranean pillars essentially created a man-made bedrock. To distribute the immense weight of the future superstructure, the engineers connected these deep wells at the surface with massive vaulted brick arches. This created a rigid, load-bearing platform that dispersed the downward forces evenly across the entire grid of wells. The continuous flow of the Yamuna River, rather than threatening the structure, actively maintained the high moisture levels required to keep the ebony foundations solid over the subsequent centuries. Part 3. The plinth and lower structures. With the subterranean foundation secured, the next phase involved raising the structure safely above the river's flood levels. The builders constructed a massive basal plinth. The first tier of this plinth was built using red sandstone, a durable and readily available material sourced from quarries near Faper Sikri. This red sandstone base rises approximately 7 meters above the surrounding garden level. Upon this red sandstone base sits the main marble platform. The platform is a perfect square, measuring 50 meters on each side, with chamfered corners that create an unequal octagon. The surface of this platform had to be leveled with absolute mathematical precision. Using rudimentary but highly effective tools, the master masons achieved surface tolerances of mere millimeters across the massive expanse. Beneath this solid-looking platform lies a complex network of hidden, vaulted brick chambers. These subterranean rooms were designed not for use, but to minimize the overall weight of the plinth while maximizing its structural rigidity. a technique that also served to insulate the main chamber from extreme ground temperatures. Part 4. The construction of the main mausoleum by the mid-1630s. Work began on the main mausoleum. The core structure of the Taj Mahal is not solid marble, as is commonly assumed. Building a monument of this scale entirely out of marble would have been structurally unstable and prohibitively expensive, even for the Mughal treasury. Instead, the engineers utilized a composite wall system. The inner core of the load-bearing walls was constructed using millions of kiln-baked bricks and a highly durable lime mortar. This brick core provided the necessary compressive strength. To protect against the frequent seismic activity in the region, the builders incorporated a network of iron dowels and molten lead to bind the masonry courses together, granting the rigid walls a crucial degree of tensile strength and flexibility. Only after the brick core was erected did the cladding process begin. The facing consists of Makrana marble, sourced from quarries in Rajasthan, over 400 kilometers away from the construction site. Makrana marble is renowned globally for its pure white color, high crystalline structure, and extraordinary durability. Elephants, oxen, and human labor dragged massive blocks of this stone across the arid landscape. Master stonecutters shaped each block entirely by hand. The precision was paramount. Blocks weighing several tons were fitted together without visible mortar lines, utilizing a system of interlocking joints and metal clamps to adhere the marble skin to the brick skeleton. Part 5. The minarets and seismic considerations framing the main mausoleum. On the four corners of the marble platform are four identical minarets, each standing over 40 meters tall. Architecturally, these minarets serve to balance the massive visual weight of the central dome and to draw the viewer's eye upward. Each minaret is divided into 3 equal segments by 2 encircling balconies and is topped by a chhatri, a traditional domed pavilion. Inside each cylindrical tower, a spiral staircase of 145 steps provides access to the top. The construction of these minarets reveals another layer of sophisticated engineering. The region of Agra is susceptible to earthquakes. The architects were acutely aware that tall, slender structures are the most vulnerable during seismic events. If a minaret were to collapse inward, it would crash through the dome of the main tomb, destroying the very thing the complex was built to protect. To mitigate this risk, the builders intentionally constructed the minarets with a slight outward lean. This deviation from the vertical axis is imperceptible to the naked eye, but mathematically precise. In the event of a catastrophic structural failure caused by tectonic shifting, the laws of gravity dictate that the minarets will fall outward, onto the main courtyard, safely away from the central mausoleum. Part 6. The Great Double Dome. The crowning architectural achievement of the Taj Mahal is its massive central dome. Rising to a height of 35 meters from its base, roughly equivalent to the length of the building's base itself, the dome creates a silhouette recognized worldwide. However, creating a dome of this magnitude presented severe structural and aesthetic challenges. To achieve the desired soaring exterior height without creating a cavernous, disproportionate interior space, the architect employed a Persian architectural technique known as the double dome. The Taj Mahal essentially has 2 domes: an inner dome that forms the ceiling of the central burial chamber, and a much larger, onion-shaped outer shell that provides the monumental exterior profile. The hollow space between these 2 domes is vast. Constructing the outer dome required immense logistical coordination. Because the dome curves inward, each successive ring of marble masonry had to support the weight of the rings above it before the final keystone was laid. To achieve this, builders erected a massive internal scaffolding system made entirely of timber. This wooden skeleton supported the marble blocks as they were meticulously hoisted to heights exceeding 70 meters. Hundreds of workers labored at dizzying heights without modern safety equipment. Once the final lotus-shaped stone was locked into place at the apex, the structure became self-supporting, and the timber centering was carefully dismantled. The dome is surmounted by a 10-meter-tall gilded finial, originally made of solid gold, which integrates both Islamic crescent motifs and traditional Hindu design elements. Part 7. Acoustics and interior architecture. The interior geometry of the main chamber was designed not just for visual symmetry, but for specific acoustic properties. The inner dome, acting in concert with the smooth marble walls, creates a highly reflective acoustic environment. A single vocalization or a whispered prayer uttered inside the central chamber will reverberate and echo for up to nearly 30 seconds. This auditory phenomenon was intentionally engineered to create an atmosphere of ethereal solemnity, ensuring that the chanting of Quranic verses would linger in the air, creating a continuous sonic envelope around the cenotaphs of the emperor and empress. The central chamber is octagonal, accessible through 4 massive arched portals known as iwans. At the precise center of this chamber lie the cenotaphs of Mumtaz Mahal and, later, Shah Jahan. It is important to note that these beautifully decorated marble boxes are empty representations. The actual bodies of the emperor and empress are interred in a relatively plain, unadorned crypt located securely at the garden level, directly beneath the main chamber, following Orthodox Islamic tradition which dictates humble burials. Part 8. The art of pietra dura and ornamentation. While the sheer scale of the Taj Mahal is overwhelming, its true artistic value lies in its microscopic details. The Mughal Empire forbade the depiction of human or animal forms in religious architecture. Therefore, the decoration of the Taj Mahal relies entirely on 3 elements: calligraphy, geometric patterns, and vegetative motifs. The most prominent decorative technique used is pietra dura, known locally as parchin kari. This is a highly specialized form of stone inlay work. Artisans chiseled precise, shallow cavities into the white marble surfaces. They then took semi-precious stones, including lapis lazuli from Afghanistan, turquoise from Tibet, jade from China, and carnelian from the Arabian Peninsula, and cut them to fit exactly into these cavities. The tolerances were so strict that the joints between the inlay and the marble are nearly invisible, even upon close inspection. These stones were arranged to form elaborate, twisting vines and blooming flowers. A single floral motif on the cenotaph or the surrounding marble screen can contain up to 64 individual pieces of semi-precious stone. The labor involved was painstaking. A single square meter of inlay work could take a team of master artisans several months to complete. As the sunlight shifts throughout the day, these polished stones catch the light, causing the walls to subtly gleam and change color. Part 9. Optical illusions and the calligraphy of Amanat, the ornamentation of the Taj Mahal, also serves a structural and psychological purpose through the use of optical illusions. The most striking example of this is the Arabic calligraphy that frames the great arches, iwans, of the 4 facades. The calligraphy, primarily consisting of verses from the Quran relating to themes of divine justice and paradise, was designed by the master calligrapher Amanat Khan. He faced a distinct visual problem. If the letters were carved at a uniform size from the bottom of the arch to the top, the letters near the apex, almost 30 meters above the viewer, would appear compressed, distorted, and unreadable from the ground due to the extreme viewing angle. To counteract this, Amanat Khan employed complex geometric scaling. As the vertical bands of text rise higher up the archway, the letters gradually increase in size and the spacing between them widens. The exact mathematical ratio of this increase ensures that, when viewed from a standard standing position at the base of the monument, the entire band of text appears perfectly uniform and legible. The black marble letters, inlaid into the white background, are not just text. They are a masterpiece of forced perspective. Part 10. The charbag and water engineering. The Taj Mahal does not exist in isolation. It is the focal point of a massive, mathematically planned complex covering 42 acres. The area immediately in front of the mausoleum is occupied by the charbag, a traditional Persian quadrilateral garden. Divided into 4 main quadrants by long reflecting pools, the garden represents the gardens of paradise described in Islamic texts, where rivers of water, milk, wine, and honey flow. Maintaining this lush garden in the arid climate of Agra required a sophisticated hydraulic engineering system. The engineers did not have access to motorized pumps. Instead, they relied on a series of purs or Persian wheels, a mechanism using animal power, usually oxen, to turn a wheel fitted with buckets, lifting water from the adjacent Yamuna River into a raised aqueduct. From the aqueduct, the water was channeled into a large holding tank, and from there, it flowed through a complex network of underground terracotta pipes. The water pressure was carefully regulated by gravity, feeding the central reflecting pool and the numerous fountains scattered throughout the garden. The fountains themselves lacked complex nozzles. Instead, the water was forced up through simple copper pots buried beneath the pavement, ensuring a steady, uniform flow that perfectly mirrored the architectural symmetry of the main building. Part 11. Logistics, workforce, and construction phases. A project of this magnitude required a logistical operation that rivaled the mobilization of a large army. The workforce of 20,000 men was not a chaotic mob, but a highly organized hierarchy of specialized guilds. There were separate encampments for stonecutters, mortar mixers, inlayers, calligraphers, and unskilled laborers. This temporary city required its own supply chains for food, water, and sanitation. Materials were sourced from across the Asian continent. Red sandstone from local quarries, marble from Rajasthan, jasper from the Punjab, jade and crystal from China, turquoise from Tibet, lapis lazuli from Afghanistan, sapphire from Sri Lanka, and carnelian from Arabia. A fleet of over 1,000 elephants and countless oxen served as the primary mode of heavy transport. The construction proceeded in distinct phases. The foundation and the main mausoleum took roughly 12 years to complete. The remaining 10 years were dedicated to the construction of the outlying buildings, including the mosque on the western side, the identical guest house, Jawab, on the eastern side, built purely to maintain architectural symmetry, the massive main gateway, and the intricate garden landscaping. During the monsoon seasons, massive temporary canopies were erected to protect the delicate inlay work and the workers themselves, ensuring that construction rarely halted. The Emperor Shah Jahan closely monitored the progress, often visiting the site to inspect the work and distribute rewards to the master craftsmen upon the completion of major milestones. Part 12. Completion and the final years. By 1653, the Taj Mahal complex was finally complete. The massive earthen ramps used for construction were dismantled, and thousands of baskets of earth were carried away, revealing the pristine marble structure in its entirety. It was a monument of unparalleled perfection, achieving an exact mirrored symmetry across almost every axis. However, the aftermath of this incredible achievement was marred by political turmoil. The immense cost of the Taj Mahal, combined with other grandiose architectural projects, had significantly drained the Mughal treasury. In 1658, just 5 years after the monument's completion, Shah Jahan fell ill. A bitter war of succession erupted among his sons. The victorious son, Aurangzeb, seized the throne and imprisoned his own father in the nearby Agra fort. For the last 8 years of his life, Shah Jahan was confined to the fort's quarters. According to historical accounts, his only solace was a small window from which he could gaze out across the Yamuna River, looking at the glowing white dome of the Taj Mahal, the eternal resting place of his beloved wife, and the ultimate culmination of his life's work. When Shah Jahan died in 1666, his body was transported down the river and quietly interred inside the Taj Mahal, next to Mumtaz Mahal. Ironically, his cenotaph is the only element in the entire main chamber that breaks the perfect architectural symmetry of the building, placed slightly off-center beside hers. Today, the Taj Mahal stands as one of the most rigorously studied structures on Earth. It is a testament not just to the emotion of a grieving emperor, but to the collective genius of the thousands of unnamed engineers, masons, and artisans whose mastery over stone, water, and gravity created a monument that has successfully outlasted empires and defied the ravages of time. Thank you for watching this detailed historical analysis. If you appreciate in-depth documentary content covering the engineering marvels of the ancient and modern world, please consider subscribing to the channel. Leave your thoughts in the comments section below regarding which historical structure we should analyze next.